strcmp, right? String compare. strcmp and other C string functions. Okay, we can do that too. Anything else? Right. So let's do, we'll start with a function, some basic functions first, and then we'll go on. We're going to just start with the not easy by any stretch, but at the same time, more indicative topics, not like structures with arrays, with loops, with this, but that gets confusing. So let's keep it as simple as I can for some of these things. I'm going to make a function. I'm going to put in my little prototype saying, I owe you one function named this. I call it sum n. You can say sum n numbers. This is a, it shows where I come from, I guess, or what I was teaching for a while. This is a classic problem in math. So the idea is, can you sum up the first n numbers? So if the number, if n is 5, it's 1 plus 2 plus 3 plus 4 plus 5. If n is 10, it's 1 plus 2 plus 3 all the way up to 10, including the 10. This is what that sigma symbol looks like when you do math. It's really, it ends up being very common because computer scientists like it. It looks really nice for examples, that sort of thing. It's also the classic example of how you can do an inductive proof if you ended up doing math proofs. This is why people like it, just because it's good for proofs and math and stuff like that. Not really great for the program, but we'll do it anyways. Okay, so here's what I want to do. I'm gonna have it's gonna be an unsigned integer. Unsigned meaning it's only positive. The number gets really, if I have 255 bits, no, I'm sorry, it's 0 to 255. Let's say I can store it in there. So it's an 8-bit number. If I have an 8-bit number, I can either represent negative 127 to negative 128 to 127, or I can represent 0 to 255. It depends on how I'm doing my number system. Essentially, it's the same batch of numbers. It's 256 numbers in total, 0 to 255. And if I do 2's complement, everything shifts over. So unsigned is just 0 to 255. That's all it means. That's all that this unsigned means. It means I cannot have a negative value. If it goes greater than 255, I go right back to 0 again. Okay, so here is what I'm going to do. I'm going to have and sum 2, let's say, the number I'm going to sum to. Right. And I'll have some kind of example like 1 plus 2 plus 3 plus 4 plus 5. That's all we're doing. The reason we want to do this is actually, it's a classic little story that mathematicians tell over and over again, these grand, shaggy dog stories where Carl Gauss, so Gauss's trick is what some people call it. Carl Gauss as a kid figured out a proof for this and confused his teacher, which is why we love giving it as an example, where you don't have to do the hardcore way of doing this. There's a mathematical formula for this, but we're going to do the hard way because, fun. So let's throw this down here. So this is, I owe you one function named sum n. I'm going to now define, so that's my declaration, so that other functions, other things can see it. And now I can define it wherever I want in the code. So I'm going to actually define it down here. Okay. Now I'm going to go around in a loop, counting from 1 up to sum 2, up to and including sum 2, just adding them all up. That's what I want to do. I know I sort of want to loop in this thing. So I could have a while loop, which the only reason I don't want to use a while loop, it's perfectly fine to use a while loop. The problem with while loops is you can get infinite loops accidentally. Speaking from experience, I keep on, every time I make a while loop, I'm like, oh God, It could go infinite. It may be an infinite loop. I write it and I forget the thing that's going to prevent it from stopping, and bad things happen. So I tend to stick with my for loops when I can. If I have to count a certain number of times, I go with a for loop. Why? Because this is sort of ingrained in me. I'm going to always start off with 0. I'm going to actually go unsigned int, actually, just because everything else is an unsigned int. Okay. I'm going to, normally I say less than sum2, but in this case, I need to include that sum2. So I'm going to less than and equals. Okay. As long as this counter that I have, this index, that's why it's this index is less than or equal to sum2, I just keep on incrementing by 1. I'm going to keep on going around this thing. Loop, loop, loop. Every time I go through the loop, I increase it by 1. So I start here. If this is true, I keep going in my loop. Every time I finish one of my loops, this happens. Repeat. I don't have to do the starting point here. I check to see if I keep going around in my loop. If so, increase. Keep going around. Increase. 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 Oh, wait, I is greater than sum2. Stop. That's how my for loop ends up working. I always, even if you don't need to, I always put in my curly braces. Because if you forget them and you add one extra line and it bites everyone eventually, it's really hard to debug, just from experience. Okay, what am I doing here now? I need to sum up these numbers. So maybe I need a variable called sum. So let's do an unsigned int sum nums. Okay, some name that I want for this thing. I have to start it off at something. I don't want to just leave it at, there's no default values in C, unfortunately. It doesn't default to 0. It could be anything. So I want to always start it off with my variables with something. Every time through the loop, I want to add it to this sum. So I loop around once, I add the 1, then I add 2, then I add 3, then I add 4. Notice what I have done here. I could have started it off at 1. I could have started it off at 1 and looped around until I get to sum2 and then stop. That's actually perhaps the better way of doing it, but I'm just a creature of habit. And if I start at 0, I do one extra loop around. I add 0 to 0 and I get 0. Doesn't do anything. But, at a creature of habit, I always put it at 0. If I've started it at 1, perfectly fine. Okay. And then I'm going to sum nums equal to, do you want to do the shortcut version of it? This means take some nums and add this next number to it. The number I, right? It's a number, it's 0, then it's a 1, then it's a 2, then it's a 3, then it's a 4, until I stop. It's my count. It's how many times I've gone through the loop, or the index, or however you want to call it. It's this number that just keeps on counting up. It's very useful because I want to know how many times I've gone through around this thing. So I'm going to add 0 to 0. I'm going to add 1 to 0, gives me 1. I'm going to add 2 to that number, it gives me 3. I'm going to add 3 to that, it gives me 6. I'm going to add 4 to that, it's going to give me 10. We can definitely go through a simple array step. What do you mean by like walk down through an array? Ryan? Yeah, great. We shall do that with, might leave off is prime. But I wanted to make sure we do something without arrays, which will muddy the waters. At the end of the day, then I need to save something at the end. And I'm going to return some nums. That is about, so this will make when I call this function, I will make a brand new variable named sum2. That sum2, the starting value of that will be based off of whatever value gets passed into my function. I do all this stuff, and then I return the value of some ends back out to whatever call this function. So let's do this. test value. Let's make it 5. So I did the first 4 values. It's 4 plus 3 plus 2 plus 1, which is 10. If I do the first 5, then it's 15, and 6 is 21, I believe. I always have to figure it out each time. Up to test value. Oh my goodness gracious. So it's an unsigned integer. That's the U. I could have used an I as well. Both would be fine. Uh, New line in there. Great. Val, that's the number I'm using, counting up to. And then I need to, what I'm going to do is I'm going to, see how I want to do this. I'm going to do it here, but hopefully you'll see why I'm doing this. So for those of you paying attention to this sort of thing, or what the heck's going on, I'm taking in some value that I'm counting up to 5, let's say. I am then calling this printf function. It is a function. I didn't write it. I'm using it. That's the reason we have functions, because you don't want to have to know how this thing works. I just want some magic thing that prints stuff to the screen. That's the point of a function. I want to do it right one time and just use it. I don't have to copy and paste code a bunch of times. I want a tool that I can use. This is a tool I can use. It prints stuff to the screen. It takes in a whole bunch of parameters. One of those parameters is right here. But first, before I do this, I'm going to have to call that function. So when I call a function, I will resolve this thing. Then that will go into this function. It's a function within a function. Perfectly okay. Functions can call functions, which can call functions, and structs can have arrays. And like, you can build all sorts of crazy things. It's normal to build crazy things. Okay. So I want to test how this works. And then I'm going to do it one more time. I'm going to just change my value for test val equal to 6, let's say, and I'm going to test it out again. Heck, what I could do, oh, I like that idea. Let's do this. For and I is equal to 0, I is less than 5, I plus, different loop, different I. The variable I down here is different than the variable I up here. That's perfectly fine. I'm going to do this. I know this is going to seem a little crazy. Hopefully it'll make sense. Plus I plus I. What's this going to do? I'm going to start off with 5, and then I'm going to do it for 6, then I'm going to do it for 7, then I'm going to do it for 8, then I'm going to do it for 9, because it's always 5 plus whatever that I value was. So I'm going to test the summation for 5, sum of the numbers up to 5, the sum of the numbers up to 6, the sum of the numbers up to 7, 8, 9, I guess, and then I'm going to stop there. I can test a bunch of different things with a for loop rather than manually copying and pasting everywhere. Notice I don't want to trust 200 numbers. The reason, this is slow as heck. It gets really big really fast. And so you can do the first maybe 30, 40 numbers, but then it starts getting really nasty. And you won't be able to know if you did it right anyway. So we can do 10. Let's do 10. Build this thing, hopefully, because I don't want to do all my code and then test it. Heck, I shouldn't have even done this much code. I should have just tested it one time, called it one time, compile it, make sure it worked, and then move on. Because I know I make mistakes along the way. If you're building a bookshelf or you're baking a recipe, you check as you go. You don't, book everything and then find out if you did things right. because invariably you did something wrong along the way. You want some way of double checking as you go. You can't sort of save it off to the end. Okay, let's run this thing and see what we get. There we go. So the sum of numbers up to 5 is 15. We calculated that, right? 5 plus 4 plus 3 plus 2 plus 1 is 15. 6 is another 6 onto it. If I add 7 to this, it should be 28. Okay, so the first 7 numbers is 28. 8 is 36. Just want to double check my math on this. 8 plus 28 is 36. Yep. Adding 9 to this should be equal to 45. Great. And I can just double check my math along the way. Okay. I'm going to leave off is prime because I think it's going to be very, very similar to what we're talking about here. It is prime is just, I walk down my numbers and see if it's divisible by that number. We can also do multiplying the hard way, but let's see about, I did the average last synchronous lecture for you guys, so hopefully I won't do that one again. Let's see if what I can do when it comes to character array. And I'll use a while loop. Okay, so I'm going to use a character. I'm going to use a character array. I'm going to use a while loop. I'm going to can I remove all the consonants? Yeah, that was one of my earlier problems I've done before. So I'm going to remove all the all consonants, I guess. Is that going to be too hard to do? I think I'll leave it like that. So here's what I'm going to do next. I'm spelling that right. All right. Some kind of function that's going to remove consonants. And I'm going to use a while loop this time, just to show other kinds of loops. I'm also going to have a character array. And what we're discovering this week is a character array is less like any other array. It's just a slew, it's just a chunk of memory that I get that I can jump in like and pretend they're like little boxes inside of it, right? It's a just contiguous chunk of memory that I can access individual parts of. What's special about a character array, or what we call a C string, a character string, is that I have a 0 at the end of this thing. It's an invisible ninja 0. It's this 0 character at the very end that you hit the end of the string when you get to that. Not when you get to the end of the array, but when you get to that character. Okay, so here's what we're going to be doing. We're going to remove all the consonants from, so vowels get left behind, consonants gets removed. I think I removed vowels. Maybe I should remove vowels. It's that's the Wheel of Fortune. I'm going to remove all the vowels from, oh no, I could remove consonants, but let's remove the vowels. It's easier. Okay, so I'm going to, this thing is going to, it's not going to return anything at all, as far as I can think of. Shouldn't return anything at all. Remove vowels. And then what do I want here? I have a character array. I want it to be an actual array that I can modify. So that's going to be something to think about. This is just going to be a text. All I'm going to be doing for this thing is I'm going to be, if I find a vowel, remove it. I'm going to, instead of just removing, I'm going to put like an underscore or a dash. Let's put a dash instead. I can't rip out things from an array. I guess I could shift everything over. That's harder to do. Instead, every time I find a vowel, I'm going to replace it with a dash character. And so all the vowels will be gone, but everything else stays the same. Okay. So here is what I want to do. I can think of this in two different ways, but I have this string of characters. I know I hit the end of my string when I hit to one of these zeros. I also know that I'm going to be going character by character, and so I might want some kind of helper function along the way if I wanted to. I don't need one But from my standpoint, I want a helper function. I want to think about this in a different way. But let's do it the way most students would do it. Okay, so I have a while loop. Let's say, let's make while a x dot not equal this character. First thing first, when I make a while loop, I'm not even thinking about anything else. I want to make sure, and I'll make this an unsigned into Excel. First things first, before I even think about anything else, I want to make sure that this thing is going to stop. That's my priority. That's what I'm always worried about. Does this thing stop? Later on, when we're dealing with pointers and the like and dynamic arrays, we'll be checking to see if this a text is equal to null, as in there's no array there at all. It's just pointing like here. It's just pointing at nothing. There are ways of doing things with memory that if you don't have an array at all, you can pass null, but we're not doing that yet. We're going to assume that this thing actually exists. Okay. I have some index that I'm going to be dealing with. Until it's equal to this magic terminating end character, I'm just going to keep on walking down my array one character at a time. I want to just check then inside of this array, what I could do is I should be checking, okay, switch, let's use a switch statement, switch a text index. So I'm going to check to see if this character that I'm looking at right now, whatever character that is, I'm going to see if it's equal to these different things. So let's say case A, case A. Remember that I don't have to, I will automatically go into all subsequent cases afterwards. So I could say, I'll do it the right way once, and then I'll show you the other ways of doing it. So I want to set that, I'm going to set that array in that position, in that box. Instead of it being the character A anymore, it's now going to be a dash. But I'm going to do that for all of my other characters. Every vowel, I need to worry about uppercase and lowercase. They are different values. But I want to remove any vowel that I come across. Oh, and then I would need to break. So if the character is equal to A, so if this character here is equal to A, then I'm going to replace it with a dash. Let me give you an example. The first character, the index is equal to 0. Is H a vowel? No, it is not. Leave it alone. Is E a vowel? Yes, it is. Replace it with, so it becomes H dash, and I'm working through my problem, right? L, well, next character. Index will be the next character. Okay, the index will be the O, which will then be a dash, and then I reach the 0 at the end, and then I stop. I want to go through a couple examples in my head before I start coding. Normally, I did that in my head, and I should have actually just manually done it this way. Okay, so I'm going through each of the characters one at a time. That's what this thing here is doing. And then I check to see if, so what for each character in this array, I'm going one at a time through the characters, and I'm going to check to see if it's a vowel. If it's a vowel, change it to that dash. So I could do the same thing again. You'll see why I'm not going to do it that way. Okay, well, I'm going to have to do that for E, I, O, and U. Well, that sounds like a big pain. So let's, instead of that, it's going to be the same, by the way. So if I go into any, that's one of the weird things about a switch statement. If I go into any of these cases, I just stay in that switch statement. So if I get to E, it will stay within the switch statement until I break out. If I had an H though, it's not there, it's not there, it's not there, not there, not there, not there. I just keep on going through cases. It's a weird aspect of switch statements, but something to point out because it comes up. If you don't put that break in there, you will find out the hard way that this is happening. That's missing something here. Yeah. And by the way, we're not using Y as a vowel. Okay. I'm going to replace whatever vowel it is. It's going to, if let's say it's an E, it goes in here, stays in the cases until I break out. Everything that's not one of those things, what happens? Nothing. I want to leave it alone. That's all I wanted to do, right? If it's an H, it doesn't go into any of these cases, doesn't go anywhere, and then just gets out at the end. Okay, I've done my switch statement. That's just an example of a switch statement. And now I need to make sure that my index changes. Index goes from 0 to 1 to 2 to 3 to 4 to 5 until I get to a stopping condition, which is this thing here. And that's it. Okay. So let's try to remove vowels. I'm going to do a couple little things here. Actually, let's just do it the right way. So I'm going to have a character array as text, and let's make its size 20 some value. That's how big my array is. 20 characters in total. There's just junk in there to start. That's it. It's just full of junk. Whatever was in there before, it's in there now. It doesn't get cleared out, doesn't get cleaned up, nothing. I need some way of setting all the values. Now I could use a for loop and just set all the characters to something, but there are functions available to me, like what we're doing this week. So strcpy string copy underscore s, hopefully cp or cpy. I always mix that up. Oh, I need to buy 20 my string classes. C string, see if that goes away. Okay. There's no instance of, okay, but this is a function. I know that because that's what this is telling me when I read it. There's two other ways of calling this thing, but there's no way of string copy that doesn't take anything, any parameters. But that's fine. I need to set values in here. So I'm going to have what you'll find out when you practice a bunch of these is you're going to have the destination, the size of my array, because it's a safe version of copying a string, and what the source is. So I can copy up to 20 characters into this thing. That's how many characters I can move over. If you go more than that, I want it to yell at you, right? If you try and pass over 40 different characters and I only have a bucket that stores 20 of them, yell, right? You don't want to just start stomping on random memory. That's why we have the underscore s version of our functions. It's the safe or secure version of it. And then here's what I'm going to do. Do you want to do hello world, let's say? Uh, I want to do upper and lowercase to see what happens with upper and lowercase. Every string, when I make a string, I will get a 0 at the end for free when I do it with these quotes. It will be an array with a 0 at the end. This entire thing is going to get copied over into this array here. I want to see this in action, so let's put a breakpoint in. And then I'm going to call remove vowels on a test text, this text that I have in here. And let's I'm just going to be lazy and change it a bunch of times. I'm actually changing my array, right? So I could just call the same thing over again, print out test text again, and it should be something different this time. Let's see this in action. I may have a compiler. Let's find out. Oh, no compiler. Good for me. I'm going to run it. It's going to stop right on this line. Let's see what a test text actually is here. So let me hover. Darn it. Darn you. There you go. Hopefully you guys can all see this. It's a big bunch of gobbledygook. It's not initialized. It's just garbage. That's fine. You just got to make sure that you clean things up before you start using them, right? That's what one of the things that catches people off guard. It's that they think it's going to be set to some safe value. No, it's just they give you garbage. It's an unfortunate aspect of C, which is a very old school language. It's very low level. It's very do it yourself. There's no safety protocols or anything like that. It's just you can do all sorts of stupid things. So it's garbage. After I call string copy, I'm going to change hello world and copy it over into this thing. Heck, we can actually look at the entire array here. See, it's all -52. All these characters. Okay, so I'm going to go one more step. That's my step over function here. And now a test text is hello world. And if I expand this out, hello world, and there's the magic 0 at the end. It is not the character 0. It is /0. It represents the number 0. In binary, that character is 0. But it's our way of indicating the end of a string. It's something special. It's a special character to say, hey, I'm done. So you don't ever see it. You don't actually walk down it. You don't hit the thing. But if it's missing, you got problems on your hands. Okay, so I get to the 11, the 11th one, and I will stop. Okay, so I'm going to print off what that text message was. Move over my output screen. The original text is hello world. Great. And then I want to go into remove vowels. I can walk into remove vowels and see. Oh, I did a step over. Sorry. I'll run the whole thing again. So I printed it off, and this is what my output is. The E is gone. The O is gone. The O is gone. It works the way I expected it to. But let's actually walk through this thing because that's sort of why we're here. I just accidentally pushed the wrong button. Instead of stepping into the function, I stepped over it. Okay, let's just walk right in here. So I'm going to stop right here. And for each character, I'm going to walk around this thing. This index will be 0, then it'll be 1, then it'll be 2, 3, 4, all the way up to 11. When I get to 11, I will stop and I will get out. Here we go. Index is equal to 0. This thing here is an H. If you actually want to see it in action, we can do a watch, I think, on it. The watch. Okay, H. Is H any of these things? No, it is not. Jump down here. So I skip all of this stuff. The index is increased by 1. So now H, the character I'm looking at is E. This thing is equal to E now. Is E equal to this 0? No, it's not. Check to see if it lands in any of these places. It's going to land right here, which puts me into this chunk of code. I'm going to now replace that E with a dash and increase the value by 1. I'm down to the L. I just loop around. Skip all of this. It's an L. It's not a vowel. Increase increase index. Skip down to the bottom. Increase the index. It's now going to be an O. I'm now going to go, when it's an O, it lands in here, goes to this chunk of code, changes it to a dash. Next chunk of code, it's a space, still a character, still allowed, not one of my vowels. Increase index. It's now a W, not one of these characters, increase the value. It's an O now. It's going to change it right here, move around. L, D, okay. And now once so I'm going, this is, the character is now D, it's at position, index is equal to 10 right now. And now let's see what happens. So index is equal to 10, it's going to become 11. The next character I'm looking at is this 0. It is now equal to the character I'm looking for. So as soon as this thing is false, so it is equal to 0, so this statement is now false. As soon as that statement is false, I stop my while loop and I get out of my and now I'm out of my function. I go right back to where I was. The vowels have all been removed in the original text. So this is what the text looks like. And then I print it out. I've walked down arrays. I've dealt with arrays of characters. I've done for loops and while loops. I've done variables. I've done function calls. And we've done kind of weird things. I've even shown what a switch statement looks like. So let's just go on. Let's see what other things we had to do. We can do multiply the hard way, but I'm hopefully, but most of these functions and for loops and stuff like that are so sort of self-explanatory, but maybe not. Let's do multiply the hard way. Why is it doing that? Okay. Four, five. Here we go. This is going to be a stupid, very, very stupid function. Here we go. It's going to be an unsigned integer. I'm just being really dumb in this case, but we're going to make a function called hard multiply. And all it's going to do is it's going to do multiplication without using multiplication. Okay. We wanted to use a loop. Here's our chance. Okay. It has to be an unsigned integer for one reason, because if that multiplier is negative, I can't do a loop a negative number of times. I could have some kind of flag and I could do kind of cutesy things, but I'm just going to keep it simple for right now. And then I'm going to use a breakpoint rather than printf statement. Okay. I'm not even thinking right now, as you can tell. Why didn't I go from 1 to less than or equal to multiplier? Because it doesn't matter. The number of loops around is the exact same no matter what. What I'm going to be doing is adding base to itself multiplier number of times. So if it's 4 and 5, I add 4 to itself 5 times. 4 plus 4 plus 4 5 times, right? 4 plus 4 plus 4 plus 4 plus 4. That's what I would expect. Okay. And if it's 0, I want it to be equal to 1, right? That's, no, I want to be equal to 0. All right, so I'm thinking exponents. Basic arithmetic, yay. Okay, so let's do this. Unsigned int total 0 is equal to total plus, that's the same as plus equals, by the way. Total is equal to total plus base. That should do it. That's it, actually. Return total. Notice I'm not even thinking in this case. I wanted a for loop. I always have the same format. So I'm not even thinking. I start at 0, go to some stopping condition, not including the stopping condition. And that's guaranteed to be multiplier number of times in this case. 0, 2, but not including multiplier, is multiplier number of times. If multiplier is 5, it's going to go 0, 1, 2, 3, 4. 5 times in total, 0 to 4. And I increase this I value by 1. That's just the formula. It makes it my life easier. Trying to figure out, oh, it's going to I plus equal to 3, blah, blah, blah. No, you're going to go nuts trying to figure out something like that. Just keep it simple if you can. Okay, this is why this is such a stupid function. But let's put this in here. Okay, and I'm going to put in my breakpoint here and hard multiply. That. Why is it cursing at me then? So I want to see what the heck I have going on here. It might be that this name of the function is different, so I'm going to just copy and paste it to make sure it's the same function name. Nope, that's a problem. Okay, so what does hard multiply take? It's an unsigned int. Hard multiply is equal to this function called the hard multiply with a 4 and a 5. Okay, this is a weird weird name for things. So let's just double check what's going on here. Unsigned int hard multiply is equal to this. And this 4, 5. This will take 2 parameters, right? Multiplier. It's an unsigned int. Let me just compile it, see if it's still going to give me problems, but it could be any number of things. Let's find out what the error is. Okay, I got some kind of weird failure. Okay, it's not taking a thing that takes 2 parameters. This is clearly a function that's taking in 2 parameters. I have 2 parameters in here. Let's see what this thing has. The base as a multiplier, okay, and it returns an unsigned int. Okay. So now I need to figure out what I'm missing here. Put that in there. And let's see if that, I have honestly don't know what the heck's going wrong with this. So let's find out. Okay. Shouldn't be a problem. Let's do one more compile. Because that is really wonky. Let's have a pointer to the function type. Oh, maybe you didn't realize what I was doing here. We hit something, a weird edge case. And it's the kind of thing that you'd have to, expression preceding parentheses of a parent call must have a pointer to the function. Term does not evaluate this function, takes 2 arguments. There's something weird going on, right? But if I look at this thing, this is called hard multiply. This is called hard multiply. Let's call it hard multi and see what happens. Your function name and your variable name cannot be the same because it thinks it's a function call, not a variable. Yeah. Weird things that are going to come up. But that's why you do a little bit of code at a time, see if it works. That should work for us now. Let's run it and let's see what happens. We're going to hit break at this breakpoint. Okay. Hard multiply is there. Fine. I'm going to go step over. And we can do step into. That would be this thing over here, F11. Wait, if I focus. There you go. F11. And now I can do, so the multiplier is 5, base is 4. It becomes 4, 8, 12, 16, 20, return 20. My hard multiplier is 20. 4 times 5 is 20. I know, that's crazy. It's one way of doing it, but it's another example of using a for loop. Okay, let's do a Polygon structure thing. So hopefully the structs are making sense. Oh, or not the structs are making sense. Hopefully these functions and these loops are making sense. It is just getting into a habit. The for loop always looks the same, but you're just trying to think about how you walk through with your, in your head or with a piece of paper in front of you, what this thing does at each step. That value now becomes 3. The value now becomes 6. The value now becomes 8. You get faster at it with time. Let's do a structure. I'm going to do I did a triangle with points before. Okay, let's do a point structure. We're going to call it myPoint, int x, int y. What? Okay. I can put a breakpoint down here, a semicolon down here. The reason I want this outside of my functions is because it's just the blueprint. I have not made point at all. I'm saying this, if you give me a point, this is what one looks like. If you give me a BIT student, this is what they look like, or this is what, they should have these qualifications going in. If I take a Carleton student, this is what this is the certain criteria that they have to meet in order to be Carleton students. That's the same thing here. These are the criteria for every single myPoint structure. This is just the blueprint. The building is going to look like this. So if I want a myPoint here, this will it will have 2 variables inside of it. I can now say pt dot, oh, I got autocomplete. Hey, x is equal to 3, pt dot y is equal to 7. All right. So a struct just allows me to wrap up related data. It is not limited to simple variables like this. In fact, I can make sure my struct is particular size. So let's do this. Struct my polygon, and it's going to have, I can have points within a struct and all sorts of weird, wonderful things. My point points. So I'm going to make an array of points and make it size, maximum size 40, or perhaps better yet, max. That way, if I want to change that value to 50 later, I don't change a bunch of 40s everywhere. I just change that one variable and everything will just work. Okay. Constantly. There we go. So this thing will have up to 40 points. I don't want to necessarily have 40 points, right? If I have a triangle, I'm still going to use this thing, but I want to say like I only have 3 points. I can store up to 40 of these things, but I only got 3 points. Okay. So what I might want to do in this as well is unsign. I can't type at all today. Num points. Write it out. I can also keep a variable around in there so that I know how many points are actually in this polygon. So if I want to make a polygon with 5 points, so then a pentagram, then pentagram has a pentagon, let's say. It has 5 points. Num points is equal to 5. There's the first 5 of these elements in the array are going to be filled in, and everything else is just left around. I'm keeping around 40 points, but yeah, who cares? If it's a triangle, I'm only using 3 of them. If I have something with 20 sides, I use 20 out of the 40 points. Right? And if I find out I'm never using more than 20 points, I can change this down to 20 to make sure that, I don't waste space. But for the time being, I'm making a nice big large number, so make sure I don't run out of points. By the way, catch me on this one because I know some people were confused by this, and I want to make sure that people are not, lost on this. I can make an array within a struct. In fact, for assignment 8, you're making an array of arrays in a struct. It's an array of character arrays. So all the different classes. If you have 5 classes, let's say you have a character array, an array of character arrays, and each one of those character arrays has text in it. Two-dimensional array. Okay, so let's see if we can do this. Let's make a brand new function. Fill polygon. Print polygon as well. Polygon. Or get polygon, read in polygon, however you want to call it. Read in polygon. It's called that. It's going to take in user input, one of the few times we get to do this, read in user input and make a polygon. And then I'm going to have another thing that's going to be a void and print polygon. Because why not? Let's actually define these things and then we'll see what we do here. Okay, I need some way of printing out a polygon. I need to get the number of points in my polygon and just get point, 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 point from then on. I'm then going to put that into a Polygon structure and return it. After I'm done with that, then I'm going to print out all the contents of that polygon. Okay, so let's do this. I'm going to make a polygon to begin with. I call it red val for return value. That's just a force of habit. You can call it whatever you want. I just need to make a polygon. This will make a polygon for me. Just like I made an integer, right? If I put the name of the data type in front, it's going to make a brand new variable called redval, which is of type polygon. So that gives me a polygon. The full array, everything inside of it, it gets me a polygon. Okay. Then I need to figure out, so where polygon. Work. There's no output there. Okay. I'm going to use scanf in this case. I'm going to put in an unsigned integer going in here, and it's going to be, I'm going to get the unsigned integer. It's going to go into this parameter. Well, I have return value. That's the name of my polygon. Dot the number of points. I can directly put it in there. Well, I need one other thing, which is I need to put like an and in front of ampersand in front of this. This is saying it's the only way I'm allowing it to actually modify the variable directly. We'll get to why we need that ampersand when we talk about pointers. But for the meantime, if it's not a character array or some kind of array, I need that thing in front. Okay. And what else do I want? That's it, I think. Okay. So what I could do is I could do this. Yes, because I like being paranoid. Num points is less than or equal to 40, or I could do the following. Oh, that's might be better. Okay, if red val num points is greater than I had a variable for it. I want to use that variable instead of 40. Let's put that in there now, actually. I think it was an unsigned integer. Right. What I wanted to be able to do here is if this is greater than the number of points I'm allowing to store, I'm going to keep on asking it for the same darn information over and over and over again. How many points do you want? Okay. And less than this number. And then I'm going to get it. So I'm going to keep on asking them until they give me a valid value. It's brute force and ignorance. You say 52 and you go, no. How many points do you want? I want 75. No. How many points do you want? And just keep on asking them over and over again. In fact, it shouldn't be just an if. It should be while that is true, keep on bugging them. As soon as you give me some valid points, this is going to be false, and I can get out. This is one of the beautiful things about a while loop. Looks just like an if statement, except I keep doing it until it becomes. So while this is true, I just got to keep on doing this, getting user feedback. Okay. I need to do some kind of scanf statement. So for each of the points. Okay. So let's do this. I'm going to do it for 1 point, and then I'm going to put it in a loop and make my life easier. Okay. So I'm going to have my point. Okay. I'm going to make a brand new point. I'm going to keep on reusing that same point over and over and over again. So let's see here. Okay. And I'm going to need this as well. Okay. I just want to have something like point count so that later on when I'm going to be dealing with this, we just keep on using this. Okay. So for point 0, what's X? Okay. I'm going to also need to do that for Y. Point 0, what is Y? And then I'm going to put another one of these scanfs in here. I'm going to get the value from the user, and it's going to be an unsigned value, and it's going to go directly into pt dot x. So I'm going to get the x value from the user. I'm going to get the y value from the user. That's 1 point. And then I'm going to stuff that point in my polygon. So here we go. Ret val dot, how many points do I have? A whole bunch of points. Okay. At position point count. Originally it's position 0. And I'm going to put in PT. I'm going to copy that point over into my array at position 0. This will do 1 point, the 0th point, and that's it. Let's compile it and see what happens, but I need to return something. I'm returning my polygon. Oh, print polygon needs to change. Sorry. Oh, I got some kind of weird thing here. What line is it on? Okay, it's a warning. And That's a sign, unsigned not matching. And because the number of points is an unsigned value, this is a int. How do I technically do this? Okay, let's compile it. That's just a warning, but I want to make sure I don't ignore my warnings as well. That's still giving me a warning. Oh, it's up here. There we go. Again, it's a warning. It doesn't actually break anything, but okay, everything's up and running. I only got 1 point in this. That's fine for right now, at least. By the way, I do have to change this thing right here. I want to pass in a polygon to this thing. And I want to see where that other. I need to pass in a polygon to print off stuff for the polygon, right? Okay. So this should read in exactly one polygon. I could actually test my code. It's not going to give me the polygon correctly, but I want to test it early on. So let's do that. In Polygon. Compile it, let's test it. Let's see what we get. Okay. How many polygon points do we want? Let's say 52. Damn, I did it wrong. Let's put in 3. 4.0, what? And maybe I should check to make sure it's 3 or above. That would be perfectly reasonable to do as well. 4.0, what is x? It's going to be 40. And for 0.0, what is y? 30. And I'm done. So so I've tested part of my code. It's not fully done, but I've stopped where I do some kind of test case. And now what I want is, now that I have this, I want to put some kind of loop in here. What kind of loop? I'm going to leave it. Actually, let's just leave it alone. Okay. I'm going to have some kind of loop in here. We have the number of points. We know it's going to be some kind of valid value. So I'm going to have, just going to put it in for loop. Unsigned int. Again, not thinking. Wait, I may not need this point count. I'm think of point count. I already have a point count. Leave that off. What I really wanted here, think of it, is not that. It is ret val dot num points. That's the number of points I'm going to be reading in. I'm going to put in I here, I here, I here. I didn't need that number of points. I could have used a while loop and then had used this point count. I just realized that I have a for loop. I have this counter, this index. Why not just use it? Okay, so this thing will just pull in X, Y, X, Y over and over and over again until I do the number of points. Then I return the whole thing and I get a whole bunch of points inside of a Polygon structure. And if you don't believe me, let's do this. I'm going to be that anyways, but I'm lazy. Let's put the name Poly the Polygon. Maybe I want something like printf Polygon has points I just want some kind of printf statement. And for each one of those points, I'm going to this point, and then I'm going to put in this value, comma, value. Let's put some parentheses around it to make it look fancy pants. Let's put a /n in there. And let's put some spaces in front of the word point. So it's going to say Polygon has 3 points, indented a little bit, and say 0.1 is this value, these values, 0.2 is these values, 0.3 has these values. And I'm going to have the current point that I'm on, the index I'm dealing with, and then it's going to be poly dot my array, and then into my array, which one am I looking at? This thing. Okay, that gives me a point, and then I can go into that point. If that's too confusing, and it often is, what I will do is this. Point per point is equal to poly dot a points. Oh, my point. Get the current point, and then just use the current point. If that makes it easier, rather than functions with a structs within structs within structs. Put the intermediate point in there, right? Dot x per point dot y. Get a new line, okay, and that should do it. Okay, let's do this thing. Here's my main. Read it into Polygon. Print Polygon. I'm going to pass poly in here. This will make a pass the values of this polygon, the values, not the variable itself, just the values. They're going to be shunted over down into this function down here. I'll make a brand new variable called poly. Happens to have the same name, different variables. This exists here, that one exists there. They're both named Poly, just like I'm named David. There's other people named David as well. This will get the values from the thing calling it. It'll be set up based on the values it gets. So it's going to be looking the exact same as the other one. And then I'm just going to go with this brand new polygon that I have here. I'm just going to print out all the values I have inside of it. And after this function is done, then poly gets destroyed. It gets given back to the system. I'm done with its function. I don't need it anymore. That's actually what's happening. Then I pass actually I don't have to pass any values back at all. It's a void function. So I just print off all the values and I'm done. Let's see this in action. And then I'm going to open the floor to more questions because I want to make sure that you guys feel this was a bit more labor intense than I wanted for the slow catch-up class, which is what the original intent here was. But, okay, so it's compiling. Let's see this in action. Let me move it over. I want a polygon. How many points do I want? I want to do 3 because I do not want to put 27 points in here. Okay, 3, 5, 4.1. What do I want? 7, 9, 2, 3. And then polygon has 3 points, 3 and 5, 7 and 9, next point, 2 and 3, the third point. Done. If I want to do something fancy with the polygon, I could figure out the areas of the polygon. I could do all sorts of weird things. I could get the perimeter of the polygons, which would be calculating the distance, figuring out the Pythagorean theorem distance, right? So the vector distance between 3, 5, and 7 and 9. So The difference between the two x values squared, the difference between y values squared, add them together to the square root, right? If you want to do linear algebra. I'm sure many of you love doing linear algebra. But you could do all sorts of different math with this thing once I have this. The whole point is it stores a whole lot of data, including an array within the structure. It has an array of structures within a structure. Let's look at this thing again. This was nasty, sort of intentionally nasty. That's why we put in the labs to try give you things to really stretch what you think a structure can do. It's not something simple necessarily like year, month, and day, which is relatively simple. It could be something complicated like I have a structure, I have an array of structures within my structure. I'm allowed that. It's perfectly fine. It gets a little unruly, which is why we do these little functions. We do little bits at a time. We figure out how to do this one little thing, test it, make sure it works, move on to the next one. If you try and do all of this all in one go, you will be driven mad. That's why we do little bits at a time. Okay. Can I unpack? I know that was a lot that I just threw at you. Can I unpack other stuff? We got another 7 minutes or so. If you want to use the 7 minutes or so, this hits a whole lot of different things. Heck, if you want, I could do the array of characters and we can remove all the vowels in an array of characters, something like that. An array of character arrays. And enum is not going to be on the exam, just letting you know. It's come up in the assignment because it's the right solution, but it's one of those things I look it up every single time. So what you had in the assignment, and it's a great thing to ask about, but it's definitely not on the exam. Just want to, in case anyone's panicking. Um, it's not that, is it? It's this. Should be something like that. The exam, that's great questions. So the like also doing this for the other parts of the class. Maybe I'll do a review email of what we're covering. It will go up to character arrays and C strings, like what assignment 8 is. It will not go to memory and pointers. Now, the original reason for that was I thought we were going to be at assignment 9 when we did the exam. That's my bad. But we will have covered the material. We just won't have an extra week of digesting what a character array is. I also will not give you something as crazy pants as a 2D character array, like what we're doing for the assignment. Okay, let's also do the straight text. Um, and so I can say something like this, which month. That is actually equal to a number, a number, a number, a number. They're all the next number in a sequence. What's the original number? I don't know. Don't care. Could be 4, could be 72. Doesn't matter. I can force it to be equal to 0. Let's say like this, but I don't need to. The point is I can just keep on referring to it as January versus the number 0. So case January, turn January. Case February. Return. Default return not enough time to type this. There we go. That should work. Nice. Is there anything you could tell us about the questions that will be 20, 30 points? I know you said that Discord that you didn't want to say the task, but the weight of these questions, it's very nerve-wracking without having any idea what the questions could potentially be about. They're going to be coding. And because coding takes a crazy amount of time, or at least a reasonable amount of time, like a multiple choice question, people can go yes, no, yes, no, yes, no, done. My multiple choice questions are not necessarily that light and fluffy. People tend to like my longer answer questions more than my multiple choice questions. But still, the multiple choice questions, people can answer really, really quickly, but they also don't show, they show some understanding, but they don't show the ability to apply. A question where you have to write code like, maybe not my month, but let's see if we have a good example. Sum n is a bit too, you can look it up online. It's too easy to look up online, but that sort of thing, right? This is a function you could write. If you couldn't easily look it up online, that would be perfectly fine. Simple 10-point question or 15-point question, maybe 15 points. If you use that plus some other code and they work together, that totals up to just say 30 points. If it's something really convoluted, it would be 20 points, let's say, or you had to think about it, 20 points. But it's meant to be about 20 minutes worth of work is how that you want to think about it. You can write it directly, normally directly in the text field, but the formatting looks like crap. So a lot of people do have their Visual Studio open because it's an online exam, unlike on paper. They have their Visual Studio open, they type it in, and by the way, if you have a compiler error, meh. Like you should try to avoid them, but don't panic if you have a compile error on your exam. Pass in what you have. Don't kill your time finding the missing semicolon in there, right? Just pass it in. If you're missing a semicolon, we probably won't even notice. The compiler will, but we won't. So pass it in, right? You're trying to do the best you can in a limited amount of time, and we know it's limited, but we're not compiling your code. We're not running your code like we do for an assignment. We're just seeing if you understand the concepts. Okay. And so the questions will be program this, like how write a function that removes vowels. That's a hard question. That's a 20-point question right there. Right? To be able to know, I need to know what not only just what a vowel is, of course, but to know how to find the vowels in a character array is one thing. To go character by character through the character array is a different thing altogether, right? So one question I can't ask anymore, but I think I put it in the sample exam, the very thrown together sample exam, was give me here is a character array, here's a string of text, find the most common character in that string of text. And I broke it into multiple different parts. One of them was, how often does this one character show up in the text? So count the number of times the letter S shows up in the text. That was one question. And then the next question was, find the most common character in the text. Well, what you do is you go character by character down this character array and see how many times that character shows up. Find the character that has that returns the largest number. So you look at the first character. How many times does that show up? Twice. Look at the next character. How many times does it show up? 5. Oh, that's the most common character now. Look at the next character. How many times does it show up? 3. So the second character is still the most common character, right? That is a big 30-point question. Unfortunately, it's a well-established question, and a bunch of people looked online, got Stack Overflow. I don't want to get into the details of it, but some people looked on Stack Overflow, found these crazy pants, very, efficient solutions. But I knew they didn't come up with it because there's no why I didn't come up with it off the top of my head. And the code is verbatim from Stack Overflow. So I try and make sure that they're questions that you would not see online. If you want to know how strcmp works, great, look it up. That's fine. I'm not going to ask a question of how strcmp works. You can look it up. It's going to be things that you've done before, you've practiced, but that you can't just look up the exact answer online. That's what we're looking for. Okay. Um, you can write in Visual Studio or See You Learn. Yeah, I've already answered, but I think you wrote that before I answered that. You wrote either place because I know some people don't want to write it in See You Learn. Some people don't want to write it in Visual Studio. Ideally, I like it on paper. The reason I like it on paper is that if you put in pseudocode, you still get a bunch of points and people feel willing to put in pseudocode. But if you have a syntax error, you don't compile your piece of paper. So no one knows they may have a syntax error and they pass it in. Versus people will panic, not pass in their exam, and they'll get 0 on the exam because they didn't submit their exam or didn't do that question at least because they didn't submit something because they were trying to figure out, a compilation error. I don't want you spinning your wheels on that. We need pseudocode comments and to accompany the code. Do you need it is different than do you want it? It's a great question, by the way. And it is a perfectly valid question here. I might ask for pseudocode. The big thing is if you do pseudocode for yourself and you cannot figure out how to do the code itself, pass in your pseudocode, right? If you have comments in your code doesn't work the way you expect it to, but we read your comments, we go, oh, that's what they're trying to do. Let's give them points. The worst thing you can do is have something really, terse and really impossibly hard to read. Let me see if I have a good example here. We got some really crappy things in here, right? If I put this thing and then .x, like if it got really, really dense and hard to follow, and it was also wrong, we're not going to be able to figure out what you were trying to get across. And since we can't figure out what you're trying to get across and you have no comments, we can't give you partial credit. Your job is to communicate that you're right. And comments, pseudocode, anything that helps us understand what you're trying to do, especially if it doesn't slow you down at all, is good. And pseudocode will help you think through the problem because I keep on hearing people, I didn't have time to write pseudocode. What do you mean you didn't have time to write pseudocode? You spent, they'll spin their wheels for 30 minutes coding, not getting it right, versus spending 2 minutes writing pseudocode so that they do the answer in 5 minutes. It's planning, but it's if you're moving, you plan before you start picking up boxes, right? You always plan before you do things because otherwise bad things happen. Your pseudocode is that planning in advance. And so if you pass it in, it doesn't hurt. Well, I may not ask for it, but you should still be trying to do it. Jeanette, does that answer your question? Okay. So it's a long-winded way of saying it, but we like comments. The reason I should put more comments in like print Polygon or read Polygon. This is because I'm doing it in front of you guys, but really I should have a little block at the top saying what this thing does so that, ideally 3 months from now, if I look at this, I know what I'm trying to say there. There you go. You have 90 minutes to do multiple coding questions, but the coding questions, if hard multiply is one of those coding questions, do you think you need 90 minutes for that? Like if you were doing that on paper, how long would that take you? So I like to think of it as pretend it was on paper, done. Just do it that way. And this shouldn't be 90 minutes. This read in Polygon, that's pretty long-winded. But if it's that's a 30-point question, it's 30 minutes to do that question. I did how many of these questions? I know I'm the professor and stuff like that, but it's you will not be expected to write something this big as a 10-point question. That's insane, right? I'm trying to get the TAs to. I've tasked the TAs to do this. I always get my TAs to take the exam, time themselves under exam conditions, say how long it takes. And whatever they take, I double it essentially. And that's how long I would expect. And depending on the TA, some of the TAs are more, you know, comfortable programming in C, and in which case it would be 4 times that amount. Any amount of time I take, it's 4 times the amount for the actual exam normally. So the question is it because of the typing or is it because just thinking it through? You hadn't noticed, I'm not exactly blazingly fast either, but you know, I wasn't typing very well today comparatively, but don't get it close enough, pass it in. The assignments, you have a bit more time to double check, and especially if you do a little bit at a time, it's doable. If you write all your code and then try and test it, it's nasty. But yeah, and thinking through is the hardest part, and that's actually the point of the entire point of the course. People say, "Well, why aren't we doing this? Why aren't we learning C syntax?" I'm like, because C syntax, you're going to forget it 2 minutes from now. The task that I've sort of set up for myself, and what the whole point of this entire sequence of courses, it's not about C code. It's about taking a big problem and breaking it down into little chunks and worrying about the scale and how it grows and how you handle things. Algorithmic thinking is directly applicable to art. It's directly applicable to running an experiment. It's directly applicable to project management. It's applicable to a whole lot of things. Taking big, nasty problems and breaking it into small, unambiguous chunks. That's why they actually teach it to biologists. And we're just trying to, this just happens to be in C, but you apply it to any language, you apply it to almost anything you're doing. And that's why it's the thing we're testing is the big, nasty, crazy problems. Oh, I actually have a TA meeting right now, actually. So I have to take my leave of you guys right now, but keep me informed of where things are getting confusing. If there's something that, you know, you're completely lost about, and let me know if you guys really want to have any kind of review session before the exam. Okay. So stop sharing. All right. This code, by the way, is online as well. So you don't have to worry about if you didn't copy everything down or if you didn't want to copy everything down, that still works. Okay, great. It's in the shared code repository. All right. Thank you. Have a good day, guys.